I just built this giant workbench in about one day, and I want to show you guys how you can make your own. It's pretty straightforward and not that expensive. It has built-in lighting, lots of space, lots of storage space, and you could use this thing as a general workbench, perhaps in electronics lab, or you want to pile a whole bunch of 3D printers on here for your 3D printing farm. Whatever it is you want to do, let's make it happen and let's get started.
And so the first thing I did was create a quick sketch of what I wanted the workbench to look like. So up at the top, there's some space for 3D printer, filament, spools. On the bottom, there's storage, and of course, there's the main work surface. Overall, I wanted the entire table to be 8 feet wide, about 30 inches deep, and sit at about 36 inches high, which is pretty standard for a workbench. And as it turns out, there is this kit that you can buy from 2x4 Basics, and they provide you with 4 resin cast legs and these stands for the upper shelf system. And so it doesn't include any of the 2x4 wood, but it basically uses standard 2x4s for the construction elements. Next, I grabbed 4 2x4s and ensured that they were exactly 96 inches or 8 feet long. And I took 2 of them and marked off locations at 24, 48, and 72 inches on those boards. On the other 2 boards, I only marked the location at the midway point, which is 48 inches. On the 2x4s with the markings at the 24-inch intervals, I cut these slots in the wood 1.5 inches wide on the center of those marks, so 3/4 of an inch on either side of those markings, and I cut them at 1.75 inches deep, which is exactly half the depth of one of these 2x4s. So the 2x4 is actually 3.5 inches deep, so it's cut at 1.75 inches deep. And I used my miter saw to make these cuts, whereby you take small incremental cuts with the miter saw, essentially the width of the saw blade, and you continue to do this until you get the desired width of cut that you were looking for. So in my case, the 1.5 inches wide. The leftover bits can be knocked out and cleaned up with a wood chisel. After cutting each slot, I test fit it onto another 2x4 to make sure that there was a snug fit. And after a bit of work, you should be left with 2 2x4s with these 3 notches in them. The other 2 2x4s with the markings on center, I cut the same 1.5 inch wide slots, but I cut them off center. So you'll see the center mark there. I cut them off to the right, and you'll see why later, but you will end up with something that looks like this. With that done, I cut 4 more pieces at 33 inches long and cut notches in both ends, the same 1.5 inches wide that I used on the 8-foot long pieces, and I also cut 4 more pieces at 30 inches long with no notches cut into them. Then I brought all the pieces down into my basement workshop and started to assemble the bottom frame. And so the bottom frame is the bottom section of the workbench. That is that little storage area down below the main work surface. This frame consists of the 2 8-foot long 2x4s with a single notch. It also has the 2 30-inch long 2x4s on either end, and in the center it has one of the 33-inch long 2x4s with the notches on both ends. And so the notches in the center of the 8-foot long 2x4s and that centerpiece there create what's known as a cross-lap joint. I'm going to secure that with a single screw and a bunch of wood glue. The 2 ends with the 30-inch long 2x4s are just simply butt joints with those 8-foot long 2x4s, and they're also going to get 1 or 2 screws in each end just to sort of temporarily hold them. In the future, when I go to assemble the whole thing with the legs will actually really secure everything together, and there's going to be a whole lot more screws in there holding everything together. But for now, this just holds the general shape. I repeated the same procedure for the top frame, which is the main work surface frame, and this one here has the 3 notches on the 8-foot long pieces of wood, and you can see that I used the remaining 3 33-inch long pieces of 2x4 with the notches at both ends. So again, these are cross-lap joints, and the reason that the main work surface has more of these than the bottom storage section was that I really wanted a very strong frame on top. I plan on putting a lot of 3D printers on top here and potentially some other heavy items, and so I really wanted to reinforce the top frame. So there's just more cross-lap joints, and otherwise everything is the exact same procedure with the screwing and gluing. Then I brought the bottom frame back onto the floor, and I began to prop it up using the legs from that 2x4 Basics kit. And those legs at the bottom have small landings on them for the corners of this frame. So you'll see here that it just lifts them a few inches off the ground. And then I can use these screws supplied in the kit to screw the legs to the frame. Now this is not the suggested method of assembly based on the instructions that come with the 2x4 leg kit. However, I think my way of doing it, I will end up with a more square frame rather than doing it their way, but I could be wrong. This is just my opinion. With all 4 legs attached to the bottom frame, I could then take the top frame and lift it onto the landings meant for the top frame. In the 2x4 Basics kit, they also show an option where you can use a mid frame if you wanted 2 lower shelf sections, but in my case I only wanted 1 lower shelf section, so I skipped that middle frame because I wanted more room on my bottom shelf for larger items. Since I have an 8-foot span on this workbench, I want to make a center leg support to make the whole bench extra sturdy. So I'm going to take a measurement from the bottom of the top frame down to the floor, which I believe was 31.5 inches, and we're going to cut some more 2x4s to that length. And so here I'm back with my center leg supports, and they're going to sit directly under the center cross member of the top frame. On the bottom, if you recall on that frame, for those long 2x4s, we cut the notch off center exactly the width of a 2x4. And so you'll see here at the bottom that it actually butts up against that cross member. And so I'm going to drive screws through one 2x4 into the cross member on each of the supporting legs. And then I'm going to drive screws diagonally upwards through the center legs into the center cross member of the top frame to secure those into place. Just a side note, but I do like to pre-drill and countersink my holes before driving my screws through to prevent splitting of the wood. The connection to the upper frame and legs is next, again using the supplied screws in the kit, and this is really going to tie everything together and provide the last bit of structural strength for this frame. Moving on to the top and bottom surfaces, I'm using 3/4 inch thick plywood for these. I had these sheets laying around my garage, and you could probably get away with 1/2 inch thick, but because again I had these laying around, I used 3/4 inch thick, and it's really going to give me a very beefy and strong table. The top is a single sheet, 8 feet long by 33 inches wide, and you'll notice in the bottom that I had to split it up into 2 sheets because of those center leg supports, and so they are not of equal length. I believe one of them is 46.5 inches long, and I believe the other one is 47 3/4 inches long, again by 33 inches wide for both of those sheets, but they will fit obviously between the legs and the center legs. I secured the sheets to the frame and cross members using wood screws, making sure to pre-drill and countersink my holes ahead of time because I did not want to split or crack my work surface. I'm going to add this thin white hardboard to my top surface to make things more aesthetically pleasing, and because I do a lot of YouTube videos, I want a white bright surface to present things on. You of course do not have to do this if you don't want to, but I think it adds a nice touch to the table. Now ideally I would have cut this in one long continuous piece by 33 inches wide, but I couldn't fit an 8-foot long piece in my car, and so I had to settle for 2 4-foot long pieces by 33 inches wide, and I'm going to be securing this hardboard to the top work surface using regular wood glue. I'm assuming this should work just fine, but if it doesn't, I can always go back and use construction adhesive. I'm going to use weights to press down on the centers while the glue dries, and I'm going to use clamps and any sort of straight edge objects I can find to clamp down on the edges to make sure that they sit flat while the glue dries. The next item on the list to tackle is the top shelf, and I bought the 2x4 Basics kit with the provisions for mounting a top shelf. So these are just resin cast brackets that allow you to take more 2x4s, stand them upright, and build yourself a top shelf on the top of your workbench. They simply screw into the top surface of the table using the supplied screws in the kit, and I've lined them up with the back corners of the top surface of my workbench. I cut these 2x4 uprights at 32 inches long, and up at the top you can slip on the identical brackets upside down and then secure them in place again with the supplied screws. And I had the top of that bracket flush with the top of the 2x4s because we're going to put more pieces of wood on top spanning the width of the table to create that top shelf. We'll see that in a second. Before going any further though, I'm going to make sure that all of the other holes meant to secure the uprights are fastened together with the supplied screws, except for the back faces. And again, we'll see why in a few minutes, but basically the brackets here get screws on the front side and on the sides, and this will really hold those uprights tight and secure so that they do not move around. At this point, I laid an 8-foot 2x2 across the top, and I'm using a 2x2 instead of 2x4s because I do not plan on putting anything heavy up there. Now this kit was not intended to be used with 2x2s, and so I had a small problem where the hole that is meant to secure a 2x4 up there in place does not line up with the 2x2, and so I'm just going to drill a hole through this bracket and then use the included screws to secure the 2x2 in place. And so here you can see that screw in place, and I've done the same thing on the other side. The front 2x2 is next, and the overall width of the top shelf is 15 inches from the very front edge to the very back edge. Now the reason I chose the 15-inch dimension is because you'll see here on my table that I have two pieces of pegboard that are 15 inches by 48 inches long, and these are offcuts from the main sheet of pegboard that I purchased, which began life as an 8-foot long by 4-foot wide piece. And the pegboard that I'm going to be using for my pegboard wall, which has yet to go up, is going to be cut at 48 inches by 33 inches, and there's going to be two of those pieces. And so if you take 48 inches minus 33 inches, you'll get 15 inches, which is the width of the offcut. And I haven't mentioned it yet in this video, but the reason that I've chosen a lot of these particular dimensions is to maximize the efficiency of the wood that I'm using. And so I'm in North America, so lumber comes in certain standard sizes. A lot of them will be things like 8 feet long, 4 feet wide. All my 2x4s come in standard sizes like 8 feet long. And so all these dimensions that I've selected minimize the amount of waste produced by this project, and therefore I'm not left with a million little offcuts of awkward sizes that you'll end up having to throw in the garbage. And so with that said, once I have my front 2x2 lined up using my pegboard offcuts here as a guide, I can do the same thing I did with the back 2x2, and I can drill a new hole in those top black brackets and drive a screw through them to secure the 2x2 in place. The next order of business was installing some large power bars on the top work surface. This is obviously going to be very convenient, especially for my application where I'm running a lot of 3D printers and perhaps some electronics equipment. And I spaced the power bars out from the back edge about 1 inch. And the reason I did this was once I get my pegboard wall up, I don't want any of the AC/DC adapters that I eventually plug into here interfering with the back pegboard. And so the extra little space will help prevent that interference. And one more item here to take care of before moving on to the pegboard is the overhead lighting. I'm going to take these 4-foot long LED fixtures and I'm going to be installing these onto the back side of the front 2x2. And the reason they're going on the back instead of the front side or the bottom side is that I did not want these things shining directly into my eyes while I'm working at my workbench. They're very bright. I already tested them out before I went to mount them, and staring at them will definitely give you a headache, so it's best to keep them out of direct line of sight. These lights mount to the 2x2 with these very simple brackets here that snap onto the back of the LED fixtures, and so they just take one screw, and I'm going to screw those directly into the 2x2 and then clip the light fixture on. Here you can see I'm using 2 of these clips per light, and I've got 2 of them screwed to the back side of the 2x2. And as I had mentioned, the light fixture simply just clips right into those directly. One other convenient feature about these light fixtures is that they can be strung together in series. And so you can see here I have 2 4-foot fixtures, basically butt-ended together. And what you can't see is this little connector here that goes in between the two. So there's a receptacle on each end of the light. The connector just pushes into those receptacles, and then you can butt the 2 fixtures up against one another to continue the electrical connection essentially. And so you can just use one plug for both fixtures. And you'll see here that when I turn them on, it is more than adequately bright. I left the pegboard as one of the final things to install because some of the previous steps required access from the back side of the workbench, so this would have obviously been in the way. Now the pegboard is going to install on the back side of those uprights, and I believe I mentioned earlier that the screws on the back of those black brackets were left out. So you can see here that I did not put them in, and that's because the pegboard has to sit flush with the back face of these brackets, and we don't want the screw heads to get in the way. And so I started by fixing one of the 4-foot long pegboard pieces to the back 2x2 with a few screws in the top side. And down along the back bottom edge of the pegboard, I temporarily clamped a 8-foot long 2x2 to act like a furring strip. It's going to add some rigidity to the bottom of the pegboard, and when the whole workbench gets pushed up near the wall, it's going to provide some space so that the pegboard hooks don't actually damage the wall behind it. So it's going to be like a little buffer space there. And what I did to secure that to the back of the workbench was drive some long screws through the backside of those 2x2s into the 2x2 uprights right through the black brackets. Then I pushed the workbench up against the wall and made sure it was reasonably level. I had to shim 2 of the feet with some black ABS plastic I had laying around. Then I could clean up the wiring for the overhead light and position the switch on one of the uprights using these nailing straps meant for electrical wires. Depending on how you plan on using your overhead storage, you can at this point fix your top sheets in place, or like me with this pegboard, leave it unfixed. And so the reason it's loose is that I have some pretty tall 3D printers, and I have some ideas here, which we'll get to in a second, for fixing spools using those 2x2s, and so I want the flexibility of being able to remove these panels whenever I want. I went ahead and 3D printed some parts to create a filament feed system that can attach to those 2x2s overhead, and it just uses this 3/4 inch PVC pipe. Now the 3D printed parts are these 2 mounts here, and then I have 2 bearings or bushings for the spool itself to go over the PVC pipe. They have 2 holes in them to clamp down on the PVC pipe so that they hold in place, and you'll see the flanges there that will hold the spool in place. And so it's clamped with these small M3 socket head cap screws, and you can just use a hex key to tighten them up. And then the mounts slip over the ends of the PVC pipe. There's a hole on top where we can use a screw to fasten these mounts directly to the PVC pipe so it doesn't slip out. This is optional if you don't have a very tight or snug fit on your 3D printed parts. I think in the future I'm actually going to remove these screws so I can quickly remove the PVC tube. I think there's very little risk of it actually slipping out. And then there's the 2 holes in the mounts that will actually mount directly to the 2x2 pieces of wood overhead. Here you can see this system sitting on top of the 2x2 strips. I do not yet have it fastened to them, but I'll point out here where the fastening would happen, through these holes directly here on the front and here on the back. Now the filament spool, you'll notice, is on the front side, so I cut the PVC pipe longer than 15 inches, and that is because depending on the placement of the 3D printer, you may want the spool positioned further ahead or back between those 2x2s, so it gives you both options as seen here. Now I could finally start loading up all of my junk and start dreaming about all of the awesome projects that I can complete on a workbench like this.
And so that's it for the basics of this build. As with all my projects, these things typically evolve over time. In this corner here, you'll see that I only have a single 3D printer right now. I have more waiting to get up on this table. In this corner, I have some general electronics equipment, and so I think I'm gonna dedicate this little area here to that, and the rest of the table will mostly be for several 3D printers. And like I said, there'll be additional features added over time. I have an idea where I want to put clear plastic partitions between the printers so that fans from one printer don't negatively affect prints on the adjacent printers. So we'll see how that goes, and like I said, over time we'll see how the table evolves as I continue to produce more and more content and projects. And so if you guys are interested in seeing more, please consider subscribing, and I hope to see you guys in another video.